Hello, everybody. So moving on to module 4 now. The module 3 homework's due tonight. And some other people have some other homework, so coming up, and I went ahead and planned for a short lecture. That way there's time to work on stuff, but a few topics we want to talk about, in particular topics to talk about. So the first one is on the list is something that is just going to be notes on the board, but it's something you will definitely be asked questions about when it comes to programming. Like common interview questions for programmers, making sure you understand the difference between these two fancy sounding words I'm getting ready to write on the board that when you read it in a textbook, it's going to sound like they're talking about the same thing. Like, there's no difference between those two things. So while I was walking around earlier today, I was sitting at a desk too much, so I've been trying to start getting my steps in. While I was walking around the halls, I came up with what I think is going to be a good example to help tell the difference, which actually combines two of the classic examples into one, that will hopefully make it make more sense and help you all to get the right answer on those multiple choice questions or interview questions where they ask about how things are related in object-oriented programming. And then we'll get into abstract classes and interfaces and start talking about that. And plan this to be a short night. That way there's plenty of time to work on homework for this class or other classes. And during our time, there's it's an active subject. I want to make sure there's plenty of time to actively do things. But starting out here, I guess I'll make up an example to put on the board. Maybe we have some sort of business situation, database or something, but we have some classes to work with, and we'll create some class, call it employee, have all the data fields we would expect, and then some subclasses that would be more specific to what each employee does. I'm gonna go ahead and throw this symbol at the beginning here. So maybe employee, we can't fill in all the details yet. So we'll talk about that symbol later. On the UML diagrams, we put a hashtag or pound sign at the beginning to show it's abstract, which means we can't make an employee object because there's details we couldn't fill in when we made that. The child classes would need them. Like one child class might be laborer, because then we know the rest of the details of what type of employee that is and what methods that particular employee would need. Or I'll abbreviate it up here, administrative assistant. Once we get down here, we don't need that abstraction. There might be certain things we knew were going to happen up here, but we didn't know all the details, like pay rates, calculating pay rates. Because both of these would probably be hourly rates, which we could put up here. But there's a lot of stuff in that class that will probably also apply to the manager class. Middle management. I'll abbreviate it again. In Java, we'd probably spell it all out, but I'm writing on the board, which is much, much slower than typing. Our middle managers are going to be salaried. So they're going to have a different pay rate calculation method than these two would. So up here in the parent class, we can't really fill that in. That's what we're going to talk about later tonight. But so previewing that. But then there's other things that would be there. Around that employee is that employee is going to have an address, and addresses are all very consistent, right? We might set that up as its own class separately. So there's some sort of address or personal information class, something that's going to need. One of the data fields in the employee class would be an address object, because we know all our employees are going to live somewhere. Or I guess the classic homeless conundrum. You have to have an address to get a job. You have to have a job to get an address. The homeless people just kind of get stuck. If you're without one or the other, it's really hard to get the other. But that's something that's going to need. it depends on it. What else might it need? Number of dependents for tax information. Some employees are going to have children. Others might be single, or again, single people, or people nearing retirement that the children no longer depend on. So there's going to be some other data in there about the dependents to put on the payroll. That's pretty good. That's a couple. That'll be enough to make the mark on the board. So both of those things are related to this. One of our UML symbols is dependency. It would depend on another class. That's an arrow, but it's a dashed arrow. And just like the inheritance and polymorphism, it points the way. Employee depends on address with a dotted line. But usually we can say something better, because address is actually going in there. It's not just a semi-arbitrary thing. How is the address data related to the employee data? And how is the dependent data related to the employee? Those are different types, different objects, but they're very related to our object. And we're going to have that in every single one. So the first of the big words I'm going to put up here, composition. The multiple classes are composed into the main class we're working with. Or we look at the subparts of that word, we can also see composite. Our class is built up of these other ones. But in particular, there's more than one type of composition we can have. The more generic form is aggregation. I started with the specific one because composite is something we use in normal English. Aggregate, you may have heard the word, but some people would use it a lot, but most people wouldn't. Aggregate is a mixed collection. So these stones in a concrete patio, right? We have the concrete, the limestone ground up to a powder, remixed with water, baked. It's not solid enough on its own, so we mix other rocks into it to add some rigidity to it, or rebar, something in there to add some rigidity to that concrete. But it's just something in there. It doesn't matter. Like, it might be smooth gravel from a river, or it might be jagged chunks of a big limestone block that was just ran through a crusher. It doesn't really matter. We get the same effect. They're aggregated in there. A pile of sand is an aggregate. So a lot of that word doesn't get used as much in common English, but it's a loose collection. So these things are going to be a loose collection. And we indicate that relationship a solid line with a diamond on it in our UML diagram. To indicate it's more than just a dependency, and that we couldn't leave it off. If it was a dependency, we could get rid of the address thing and it wouldn't make any difference. Because then we wouldn't know where our employee lived. Or if it was a dependency, we could leave this off, but then we'd get their tax information wrong, right? That's going to make a big difference on some people's tax incomes. Because if you say in advance that you have dependents, they're going to take more out of each weekly check, and you get a bigger check come tax refund time, which with other benefits on tax forms adds up to a lot more tax benefit that parents kind of learn to rely on over the 18 years while their kids are growing up. So we wouldn't really want to leave them off like it was just a dependency. We wanted to take that a step further and do that line with the diamond on it to say it's either aggregation or composition. Aggregation is the open diamond. But some of these are more important than others. I mentioned homeless. Would we fire somebody just because they got kicked out of their house and temporarily didn't have an address? Probably not, right? They're gonna keep their jobs, so they could leave this address. They could go to a different address. It isn't as tied to it. Their children, on the other hand, are like a piece of them. They're not going to be separated from their children, right? Usually not without at least a lengthy court battle. So it's much more a part of it, a composite of what this virtual object is representing from the physical world. So composition is the step further. And it gets a filled in diamond. Is that still on the screen? Yeah. So we'd fill in this one to show that it's more important. There are different standard examples. That kind of makes sense. Those things are related. One of them is just kind of loosely related. We can switch to any other address. Could probably get by for a little while if there was no address. But it's not quite the case on the other side, right? If they lost their home, they'd get by occasionally for a little while. If they lost a child, they'd probably be depressed forever. That's why of the standard examples, this is one of my favorites. That lose your home or move to a different home, that's recoverable. But lose a child leaves an impact on you. So it really highlights that. But that's not the only standard example. I'm going to erase this one and put the example I just thought of while I was walking earlier today that I think will help make this a little clearer. Because we'll have to answer questions about these. Aggregation is the loose relationship, and composite is the more necessary form of aggregation, like the more detailed version of aggregation. So another very, very common example, actually, I'm going to combine two very, very common examples. One of them, I'll put over here small. You might have some sort of person data representing a human. And some standard parts of that would be like the parts of the body, making up that person. The object is the head, the legs, the arms. That's probably enough for now. And all the different parts of the body. Or another common example would be like student records. And classes tend to fall back on those because most students are familiar with, if we use student records, student IDs and things as examples. But the student records would have a couple in there as well. So like an address again, and maybe a name. If we look at these two, which one's an aggregation and which one's a composition? Again, the student could move to a different apartment. A student could be homeless. We're not going to kick somebody out of school because they're homeless. This is a community college. That happens sometimes. I know a lot of things are virtual now, so y'all haven't been on campus to see it. But sometimes there are homeless families, and they have to hang out all day with their kids, like kids and babies, and all day or parking lot is they're trying to get somewhere better. You see that a lot more community colleges than at big universities. There's a couple that always spring up first in my mind. It was several years ago. They both graduated. I think the latter one graduated in 2016. A year a little behind me when I was a student employee, but they both grew up in an orphanage. So when they hit 18, they had nothing except a newborn baby. They pretty much lived in the parking lot. Other people got used to just seeing them there. Nursing students would kind of babysit their kids when they were in class and stuff. So address is not dependent. A student does not really need the address at all. It's just kind of useful to have an address. A name cannot be separated from that student, right? Or the address would continue to exist, I guess is the thing. The other way to say it. The address would exist whether that student lived there or not, right? That's a building, a location. If the student's there, it's a student address. If the student doesn't live there, it's still an address. But this student's name would not exist without that student, or student ID, or things like that. Unique, it's uniquely part of it. So we see a couple words. I'll write on the next one. So that's two very common examples. Oh, I didn't color these in. Usually in this example, right, the head, we could lose some of those body parts and still live. So it's a more extreme example. But I'm walking around earlier, I thought, hey, that might make a good combination to explain it and see it all at once. Because that student object, there's going to be two relations to it. One thing in there is it has an address, but a student indicates it's a human, so it also has a head. They're both aggregations, but one of them kind of can go a step further and be a composition as well, right? And I just phrased it in terms of that address is going to exist without the student. If we look at the central part, if this way makes more sense in your mind, what can the student exist without? The student can exist without an address, but the student's not going to exist if we decapitate. This one's a much more important relationship. We can kick them out of their apartment and they'll still survive. If we cut their head off, they're definitely not going to survive. Different ways to view that. The composition is like a child of aggregation. It's a more detailed version, but a higher level of relationship between the two things. So you can ask that question as, does this exist without the thing it's related to? Because the address can exist without a student. Or a name or student ID that could exist, that's not going to exist without a student. Our database isn't filled with random IDs that don't connect to any student, right? Every ID in the database, or student ID in the database, connects directly to a student. A lot of times addresses will be wrong because the average age for a college student is probably only going to stick around for a year lease, right? Sign a year lease, then go to a different apartment a year later to different apartments. By the time you finish school, you'll have lived in a couple different addresses, and not everybody runs over to the admissions department and upgrades their paperwork as soon as they move. It's like, yeah, the school has my phone number. They can get hold of me that way. So the importance of that relationship shows it. A name or ID. I keep saying ID, so I'm just going to switch to that. The student ID could not exist without the student, but the address will continue to exist without the student. And it goes the other way. This is the one I was thinking of. Just combine those two standard examples. The student can exist without an address, but the student is not going to exist without a head. So that continued dependency on it. And there's some normal English words that are standard to help us think about this. On a composition, we would say that that's an is a relationship. A head is a student. And a aggregation is just going to be a has a relationship. A student has an address. A student is a head. That came out about strange. A head is part of the student, but it's not going to exist without it. Same thing over here. A student is a student ID. That's our unique identifier in a relational database. That's how the database uniquely identifies that. So it's a one-to-one relationship. It is definitely a single thing. A student has an address. They can move to a different address. There can be a dozen students that live in the same apartment or the same frat house. I guess a dozen's kind of big for an apartment, but an entire fraternity can have the same address, right? That's part of the point, is those living arrangements with fraternities and sororities on the traditional university. Get the nice living arrangements in a big house instead of the little big dorm room you share with some random stranger. But the ID is a student, and the student has an address. So those two words can help think about it. You just want to make sure you understand the difference in those concepts, because you will have to answer questions about that over and over and over again, like multiple choice questions in this class, probably in some other classes as well. When you take your SDEV 265 class before you graduate, that class is getting ready to start running IB online, but otherwise you would take it from me or Chris up at Fort Wayne, in which case you would definitely be graded heavily over that showing up properly in your UML diagrams. That class is a big project, and it's one of those where I grade the documentation and the UML diagrams, group work, and then seeing the program run at the end is just for your own benefit and excitement after all the documentation and thinking you put into the project. I think Chris does it. The other Chris up north does it the same way. But you'll definitely see it in multiple classes along the way, and it is something that will show up in job interviews for software development, making sure you know the difference between aggregation and composition. So something we don't simplify the terminology of when we talk about it, but these are the standard words we use in English to help keep that straight. So we'll make sure you get those concepts down. Or that earlier example that was erased. That employee is their children, their dependents, right? That's a part of them. You can't separate them from their children without some serious psychological impact. But you can definitely pull them away from their house without any problem, or without as much problem. Move them to a new house. Yeah, let's think about that. Move into a bigger house. You can upgrade them to a nicer subdivision and, without psychological damage being done. But the importance of those two things, and make sure you remember the words and kind of, does everybody feel comfortable with that? I see head nods in the class. And yeah, I just spent a lot of time reiterating that, so hopefully just from all that reiteration, you understand that that's going to be an important one. It often seems subtle when it's first introduced, but it is something that will be a big deal. So make sure you get those right. Oh, certification exams, I missed those two. Because that certification exams directly apply to paychecks, right? Even if you already have a job as a programmer, when you get your next certification, that should equate to a raise. And you'll definitely have to answer the question there. If you have a job, it equates to a raise, and if you don't have a job, it equates to finding a job. So certification exams are kind of important. And again, we don't get certified in Java by writing Java programs. We get certified in Java by answering multiple choice questions about Java. Very, 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 very similar to your weekly quizzes here. Almost to the point that it looks like the person who wrote those quizzes is taking the certification exam. Instead of using questions from the book, they pulled their questions from somewhere else. I don't know where I got the folder there. So that's aggregation and composition. Shows up in our UML diagrams as something stronger than an arrow. So whenever you're using draw.io or something to put your class diagrams together, you can put that on there. Usually the generated ones, we'll see that before long. Your assignment this week involved drawing a UML diagram. So I was gonna wait till after you drew one by hand before we look at the generated ones. Because those of you who have done that so far probably noticed it doesn't take a lot of thought to do that. It's a good planning thing. It can be helpful for planning. But when we've already written our code, which is what you probably did for the homework, it doesn't really take a lot of thought to put the class diagram together. And that's nice because computers are great at performing tasks that don't take a lot of thought. What does take a lot of thought is organizing. My favorite one of the generator things will draw all those class diagrams, but it will put every single one just stacked on top of each other in the upper left-hand corner. So we have to reorganize because organizing that can be a little complicated. The examples I draw on the board are simple ones, so we put those in the notes. But you can probably already see how, as it grows large, that's going to be complicated. We'll have those arrows crossing each other and relationships going back and forth. Do I have any I can open? I bet I can look at a more complicated one really quickly here. I have to go to Drive. If I open it locally, I don't think it'll open with draw.io. All kinds of nice stuff, programming things. Oh wait, I have something I get out of the work. I don't know where I get started trying to go there. I think there's some best. No, that's just the database order. Simple. Maybe that doesn't have it. Every once in a while, I do documentation for my projects. Anything on GitHub is either a personal use thing or something that's not finished yet. I move stuff elsewhere whenever it's finished. Oh, this one has class diagrams. So this one has a lot of diagrams. I'm scrolling, you can see there's still lines crossing all over the place. Things pointing at different things with dependencies and relationships and a lot going on. And I had to make this kind of big and still couldn't completely avoid lines crossing. This one has to inherit from stuff here and connect to that. This one has to connect to the things up here. Some stuff goes back and forth different ways. So you see there's a lot more thought goes into organizing it on the page and trying to get it readable when you have all those arrows and lines going everywhere. That's not even really a complete diagram. That was enough that I could keep track of it while I was doing a big project management thing. Project management software always goes by the day or week at best. I like to use that software for classroom lectures. Go back and forth, set up different charts that we would normally use for budgets and things to show like difficulty level. That way it goes back and forth. We're not just constantly getting harder and harder and harder. After we cover a complicated topic, we jump back and cover an easy topic, things like that, and plan out how the lecture is going to go. But project management software is set up for days and weeks and months, and not minutes like I need for a lecture, or hour at the most. So I had to make my own, basically. So I did one that goes from seconds up to years. I was like, this will cover my needs and produces a lot of charts and stuff, so I can help me plan out the lectures. So I guess the next one in the Java section, I could have kept sharing my screen. Again, I had something in mind, the whole planned out lecture, and then right before class, I thought of a new way to introduce this that to help show the need of it. The next thing is one of those that sometimes it's hard to see the need of it in the introduction level. And it's like, I guess I'll just say it in one sentence now. You'll have to take my word for it that it really is something that pays off big time. But that's really hard to see in an introduction class, like something 200 level Java where we're under tight time constraints. So even our biggest projects can only get so big. They have to fit in the semester. It's kind of hard to see the benefit of this stuff, but it really will pay off later. And we've actually already kind of used it. So let's see. Our object example 1, that was our animals object. Let's look at something here. So we created this data class. You might remember from a couple weeks ago, kind of thinking roughly about like a vet office or something, but something to represent animals, and we just kind of went with it. We had some examples. We came back to it a couple times. Oh, we even put an array in here, array list in here, and we worked with those a couple weeks ago. We can sort arrays, right? If I make a new array list with integers, equals new array list. And, oh, whoops, I need a name. Numbers. I can say things like numbers dot add 7, numbers dot add 3, numbers dot add 9, numbers dot add 2. Just a few numbers in there, nothing in particular, nothing special. But an array list also has a sort method. So we can say numbers dot sort. Does the other one work? Array dot sort. Let me just make a regular array. I know I can sort it as an array. And numbers equals 3, 7, 2, 9. So it imported the wrong thing. I was trying to look at something we looked at before. So I'll just skip this. I'll use the one here. So we created this animals object. And when we were looking at arrays, we saw a sort method. I was just making that up. I'm going to skip that because I'm apparently making typos. But that sort method didn't know what to do with numbers, letters, words, and our primitive data, right? But what if we need to sort these? That becomes a problem, right? Because what does it mean for our animal objects to be in order? We say animals.sort. We get this error message. This is what I was actually planning for the thing. We have no way to compare those. Right? We made equality on this one somewhere here. Yeah, we've defined what it means for two animals to be equal, but equal doesn't give us enough to sort it and put it in order. Which one's smallest, which one's biggest, any of that information. Not quite enough information there, so we can't call one of our fundamental methods from the array list with that. Let's take that. What about our other one? Oh, did I save something? I didn't mean to. guess I did say so. I might still point back to that example sometime, so I don't want to go messing it up. Oh, on our vehicle object, we did have something for a way to compare. And actually, we're required to do that. If I take that out, control cut. See, now we're getting an error message because of up here, vehicles not abstract. We use this interface, which we're going to start with calling interface a set of rules, things we agree to, so that something else can work with it. And the comparable interface is a rule that says anything that has this interface will have a compare to method. So then we can do that inequality, greater, less, or equal, or really greater or less, because we have the equals method. But usually we go ahead and include that equal as well. So it was a set of rules so that things can be compared. We have a way to compare them. If I do Control Z, yeah, I'll put it back in there. So that has a way to compare stuff. In particular, we agreed to do a comparable, we agreed to make it comparable. So as long as we compare it to other things that are comparable, we have a way to put them in order. So can we do the same thing here? Can we make a list? Oh, I started doing it before class, and I guess I could have kept that on there. That was from when I did a quick test to make sure it would crash like I was expecting to. Yeah. Again, looking at the crash here. And by the end of the lecture, we'll see how to fix that. Array list vehicle, I'll call it cars. Gonna be a new array list, nothing new there. We saw those a couple weeks ago. And then we can add some stuff to it. So like cars dot add maybe a Ford Taurus. I'll say 1994. That was the year the Ford Taurus ones were really good. Oh, whoops. Add a new vehicle. I can remember to type all the words. So we'll just throw in a constructor here and create a new vehicle and add that to the list. And add some more. A new vehicle. Maybe a Jeep Wrangler. 2022. Cars got to add a new vehicle. Chevy, Chevrolet. Let's spell that out. Camaro. Maybe one of the original early Camaros. I don't think 78 was the first year. But 78 was a really nice Camaros. Oh yeah, Camaro was out in the 60s, wasn't it? 78 was when they went to the squared off the body. They started squaring off the body and slanting it. It started to look like a Firebird around there. But we have a couple vehicles. And if you remember when we were talking about the use on this, it was putting things in alphabetical order or some sort, or it was showing cars in like a chatbot or something. Use cars. So we might want them in alphabetical order or order by year. I think that's what we did for comparing them. Yeah, we were just looking at the years when we compared them. So they are compared. We can put, there is an order defined to them, but if we try to use that sort method, again, it's still throwing that error message. We still haven't met the requirements to do that. So in order to use the sort method in the arrays, we need certain things. It's also collections.sort. That one right here. Collections.sort. Oh, collections.sort, and looks like from the thing here, we can sort a generic type of list. That one doesn't throw an error message. And there's only one thing in our class that the computer could look at to tell what it means to put those in order, right? So our collections static class, we can tell it's static because we use the class name instead of an instance. The sort method there is going to use our comparable interface, or in particular, the rule from the comparable interface to figure out what the order is. So as long as we have that comparable interface and bring in the compare to method, we can use that sort method. So it's a set of rules. The interface says, okay, we're gonna anything that wants to have this interface, or if we use that as a verb, anything that needs to interface with the collections.sort method, using that as a verb instead of a noun, has to follow certain rules. In particular, it needs to be comparable. And to be comparable means that it has the compare to method. So that's what's meant by a set of rules. We're setting up a set of rules that it can follow. So now we can print that out. Fine. So if we print that, why does it give me an error message? I'm not sure where the error message is coming from. We'll move on to the current stuff, but we have that rule versus the other one, the built-in, the array list.sort. It's asking for a different interface. It needs a comparator interface instead of a comparable. So that method requires a different set of rules. So we need to look at what's meant by those, by things like rules like that. I'll just clear that out. I was just introduce it and kind of preview showing one of the places where those rules will show up. So when they made that sort method, either one of those sort methods, they had no idea what sort of bad objects we make in the future. Array list has been around since almost the beginning of Java. And I don't mean version 1, definitely version 1, but I mean like early in the development of Java 1. Array list has been around that long. So they had no idea what type of objects we would be making in 2022. But they knew that we would want to put them into an array list and then put them in order. There's a good chance we would want that. So they had to get things ready. And that's where an interface comes in. It's basically the starting point is it's a set of rules that allow us to work with something long before it's created. Or for what we're going to do on our homework and stuff, it's a set of rules that we agree to follow when we make an object. There's also some type casting advantages we can do with that and stuff. But before we get to looking at the rules, let's look at abstract classes first. So basically, an abstract class is a class that's not finished. It's not quite finished all the way. Can't work at it. I'm going to go back to the object example and just modify this to look at that. So our main thing was this animal object. Did a bunch of stuff, counted them, had information about it. And this default method that said, okay, our general animal is going to make the sound roar. Seems like you can catch all. And then we overrid that a couple times, like a cat obviously isn't going to roar. Or a dog's not going to roar. A fish isn't going to roar. if we start thinking about that, there's more animals that are not going to make a roaring sound than that will. So that might not be the best default. In fact, there's so many different sounds that are going to be made, it's hard to say what it would be, right? So we have a couple lions. They would make a roaring sound, so that would work. A gorilla can make a roaring sound, but there's other sounds that a gorilla is going to make more often when it's not directly attacking something, right? It'd be a rare sound to get from that one. It probably wouldn't be our default sound from that animal. Something about the grunts and the combination of grunts and size that gorillas make. Cat, not gonna work there, or a dog. Or down here, we just made animal objects called fish and eel, and roar definitely doesn't work for those. So it's kind of like we might have jumped the gun putting that default value there, right? We know all of our animals are gonna make a sound. So no matter what, we know that we're gonna have a public string make sound with this data class. And we know that's going to be there on every single thing we do. But we don't know what sound any particular animal is going to make. So we can't really do this part yet. We take that out and just throw in the semicolon. See it right there in the message. Missing method body or declared to be abstract. So we have to do one of those things. We know that method is going to be there, but we don't know enough details to write that method yet. So what we're going to do is add in a keyword up here to say public abstract class. So it can't actually be instantiated yet. Put that in the wrong spot. I have to put it down here. And that abstract class has an abstract method. So we need both keywords. Make the little red dot go away. So that's saying we don't have quite enough information yet for it. We know it's going to be there, but we can't fill that in. So coming back up to the board and drawing this picture again, or the simplified version, we have animal, but we don't know enough details to actually make the animal class. We're still missing what is going to go in that method that we know we're going to add. So that needs to be abstract. So in our UML symbols, in the UML framework, abstract gets the, whatever you want to call that symbol, pound sign, hash key, hashtag, lots of different words, number sign, but that shows that it's abstract. And we can't quite implement. But when we make the child objects of that, what do we have? We had a lion object. And a cat object. A dog object. And those other two are going to be a problem right now. Because the fish and the eel, they're in our test case, we just said those are animal objects. But animals abstract, we can't instantiate. Because we don't know what sound the animal's going to make. On a lion, a cat, a dog, we know what they're going to make. Right? I guess I'll put both of them in here. We could probably make up a sound a fish is going to make. Boop, or the sound of a bubble coming up from the water, splash, something like that. We can make something up. Same thing for an eel. Whoops, that's not how to spell eel. There we go. Same thing for an eel. We could make up a sound. First thing popping in my mind is like the electric eel. We could say that, or something along those lines. But we know what sound it's going to make by the child object. So Our parent is abstract, but all of our child objects will be concrete. So a couple more vocab terms there. Concrete objects, concrete classes are the ones we can instantiate and make objects out of. They're solid, they're complete, they're finished. But the abstract is just not quite finished yet. We know we have that method, we just don't know how to implement it until we get to the child classes. So if we look over here, we started to get these error messages on animal and on fish and eel. So we don't have sounds for those. But some of them we got error messages and some of them we didn't. If we look over here at the projects panel, cat, there's no error message. Coverings and enum, and dog, there's no error message. But we still got an error message on gorilla and lion. And then that one in the main class is just carrying back through from the others. We can't run it until we fix the other error messages. What's different about cat and dog than gorilla and lion? We already did an override on that. Yes, we know what sound, we already filled in what sound they're gonna make. So we need to do the same thing for this. And notice the error message here. Gorilla is not abstract and it does not override that method. It doesn't make a different sound than the parent yet. Which we can do in NetBeans by alt insert. Is Craig right here? Nope, he's not. He went to use VS Code. If you're watching the video later, Gregory, VS, I get hold of an email. I found a plugin that will do code insertion on a keyboard shortcut for VS Code. Since you weren't wanting to use NetBeans, but it's not in English. So it wasn't an American that wrote it. So sometimes it messes up a little in English, but that was one I knew was going to be lacking. So I did look for that for you if you watch the video later. Or other people that like VS Code. I found the plugin, but it wants to write it in Italian, so it doesn't translate to English very well. But it's better than nothing. So we can do alt insert and override the methods. And you see here's all the ones we need to override. Equals covering. Get age, get covering, get name, get weight, get checkout. But you'll notice make sound is not on our list. So it's not an override. If I click this, instead of override, there's also implement all methods. That's the one we want. I think there's an implement on the other list as well. Alt insert. So instead of override, we want to implement methods. And now we don't have the one option. It's like there's an abstract method that has not been filled out yet. Generate the code or type the method, either way works. And it's still an override. So if you type it in, make sure you put @override. If you use the keyboard shortcuts, make sure you look for implement for those. And it didn't know what to do, so it just threw an error. We'll see error handling soon. So instead of a try catch block, we can also throw it, which means make this error somebody else's problem. Pass the problem on to somebody else, which is a problem for humans, right? Make this error somebody else's problem is a big deal for humans. Your coworkers will get very, very upset if you do that. So for software, that's often a much better way to handle it than try catch. We'll see that soon. What do we need to do? We need to return a string where we got gorilla. I don't know, grunt side. Something like that, just some string in there. we'll need to do that for all of them. So our lion as well. It's not there, so we need to implement the abstract methods and do something better than just throw an error message. For the lion, roar will work, return roar. That does sound like the appropriate for a lion. So I fixed all those. The eel and the fish, we don't have classes yet, but remember how easy it is to make those with the code generation. Just make a new Java class. We need a fish. Finish that. Get rid of this stuff that I probably should have taken out of the template already. Remember, we can customize the templates in any IDE, not just NetBeans. NetBeans is exemplary. The main reason we're using NetBeans because that is the official IDE for Java. Java is owned by Oracle. Apache is a subsidiary of Oracle. So Java, Oracle also owns Apache. And so when they needed to pick an official one, they went with the one they owned, basically. They went with one that they were a parent company for the actual owners of it. Is the reason we went with that. But it's exemplary. We will have the same functionality in any of our major IDEs. Just the buttons are in a different place, but I assume in our modern world, you don't know how to deal with that, right? You know there's a button that does it, you just don't know where it's at in the software, so you have to look around for it, hover over things and all those normal ones. So again, we'll use the keyword extends to say this is a child of the animal object. Implement the abstract methods. I have to do that first, and we probably need some constructors. So I'll insert constructors so we can make a fish, and I'll just do both of these. I didn't really do much typing there at all. On the IntelliJ IDE, whenever you go to do a new class like this, say eel, and then right below it, it says what the superclass is. Oh, it's right here. Oh, okay. I've never done that in NetBeans before. I never really looked through it. The other one, you type it in right at the second box, but here down at the bottom, there's a text box, but we can't type in that. We have to browse and find the other one. Look for animal. There it is, animal in the object example 1 package. So that's what we want to be a subclass of. Then we hit finish, and we don't even have to hit that extends part. Let's get rid of this stuff that's just cluttered here. Right click, implement the abstract methods, and insert a couple constructors. And we'll get the getters and setters from the earlier one. There wasn't really any typing at all to make that. Remember to let the computer do the typing for you. Computers are better than humans at typing. So anytime the computer can use predictive text or code generation, the computer is better at typing than you are. Because I still mark up, just haven't cleared that yet. So now, our animal object can be a fish or an eel. But notice on this side, it's an abstract type. So that polymorphism we talked about, like passing into methods, we go as far up the chain as we can to the object that's going to have everything we need for that to run that method. We can do the same thing with our type. The type can be abstract, but the instance where we call it the constructor has to come from something concrete. Or is that still showing an error message? Oh, suspicious it's a probably. Oh, it's way up here. Oh, this one can't be an animal. Again, our constructor has to be something concrete, but the type can be abstract still, and often will. What is this? This is one we didn't know. I'm just going to put line just to clear out that error message. That was from the other example. See, now everything should still work the same. Oh, but a couple of them do not call this other method. Would that not work? Oh, oops, I never made the sound. It was still throwing an exception. So notice sometimes looking at the error message, you have to go back to things. And that means the error messages conveniently give us links right to the stuff. You didn't notice that when I was clicking there. I can click down here. It goes to, okay, so the last thing the computer did was lump run line 52. That one worked. And then this line's where it crashed. It actually crashed because of this back up here. So if I undo, I never actually put something in that method. Return, whoops. Return that. I'm just thinking an electric eel. So like some getting shocked sound. It's gonna work, but we're still getting error messages in different places. What's this one? Oh, I didn't do the fish one either. I guess there was some typing on that one. Was it fish or eel that we didn't type in? I think it was eel. So that, yeah, there is still some typing. We can't get away with no typing. Return oop. I guess that's kind of the sound of a bubble would make. Floats to the top of the water and oop, as it pops. There we go. Got all the messages, and notice when we made animal, the one that this method actually requires, we couldn't create or make sound method. We didn't know enough. But that is the only method we actually needed. Everything else was just getters and setters and some of the basic stuff to make a Java class work. The only one we actually needed was to make sound, but we couldn't make it when we made this type of pattern. So by making it abstract, it forces us to put it in any child objects so that anything we will actually use in this method, we know that it will be there. Kind of like, that's kind of the introduction to what we're going to look at after the break. It created a rule that we then had to follow. The compiler wasn't going to compile the code until we follow the rule that we have to make a make sound method and turn any subclasses into concrete subclasses so they will run. So hopefully from that you probably have enough information to already predict what an interface is going to be. But let's take a quick break before we do that. Can that sound good to everybody? I see head nods here in the class. It's okay on the Zoom call. Let's see, my laptop says 7:05, so we'll get back to it at 7:15.